Problem number 7, solve for the domain of f of x, which is equal to the square root of 10x minus 5 over x squared minus 16. So here, the function f of x is composed of numerator and denominator, and the denominator should not be equal to 0, as we always use for the condition, such that function f of x will not be undefined. Or else, if the denominator is 0, then it becomes undefined. Now, the numerator is a radical expression, and it is a square root. So which means that the values of the radicand 10x minus 5 should be greater than or equal to 0, or else we would get a function value which is an imaginary. So we restrict our values to be real, right? So these would be our two restrictions, okay, that we're going to consider. Oh, by the way, now, is there a value of x such that the function f of x becomes indeterminate? Or in short, or in other terms, the numerator becomes 0 and the denominator becomes 0 at the same time? And I don't think so. There would be no, because if ever there is, the numerator, the value of the numerator should be 5 over 10. And if x is 5 over 10, the denominator is not equal to 0. So there's no such value of x that would make f of x becomes indeterminate. So let's consider two conditions, okay, that we need to solve. So let's consider the numerator first. We know that 10x minus 5 is a radicand, and it should be 10x minus 5 should be greater than or equal to 0. And I hope you already knew the reason why it becomes greater than or equal to 0. But then again, if it becomes less than 0, the radicand or the numerator becomes imaginary. And we don't need, or we're not talking about imaginary numbers here. We're talking about rational numbers or real numbers, sorry. Okay, so here, let's solve for the value of x. So we have x is greater than, or 10x is greater than or equal to 5, and divide both sides by 10. So x is greater than or equal to 1/2. So the value of x would be greater than or equal to 1/2 for this expression to be real. All right. Now let's go to the denominator. X squared minus 16 is not equal to 0. So in this case, let's try to analyze what are the values of x that would make this given statement, this one is true. So I mean, not what are the values of x that would make x squared minus 16 equals 0? Okay, 16 is a perfect square, so x would be a positive negative 4, right? So let's check if it's really positive or negative 4. So let's solve. X squared, let's solve, is not equal to 16, and we can take the square root on both sides. So x is not equal to positive negative 4. So our analysis and our solution have the same answers, which are positive and negative 4, which means we don't want positive negative 4 to be the value of x. Why? Because it would make the denominator 0. And if the denominator is 0, it becomes undefined, or the function becomes undefined. So we're going to consider this and another condition, this one. So how do we write our domain now of the function f of x? So the domain of the function f is equal to x, which is an element of real numbers again, okay? However, x must be greater than or equal to 1/2, all right? And x must not be equal to positive or negative 4, okay? Now let's check that using the number line. Let's check if it's really, these conditions or values of x that defines the domain of the function f. So let's plot the points in the number line. Okay, let's say this is 0, this is -4, uh, this is 1/2, and this is 4. So let's sketch the points. Okay, now here x is greater than or equal to 1/2. So kind of here, right? Okay, so these are the points. And x is not equal to 4. So we need to consider, or we need to remove this 4. So this is hollow. All right? This is hollow. So, and also x is not equal to -4. -4. However, the points or the intersection of the two restrictions can be found here. Here. Wherein +4 is not part of the solution and it's part of the restriction. So therefore, our final answer for the domain, okay, the domain of f is x is an element of real numbers such that x is greater than or equal to 1/2, but x is not equal to 4. So this is our final answer, final answer in the domain of the function f of x. Okay, so we need to check the, what they call this, the intersection of all the conditions that we found from the numerator and the denominator using the values that we got here, all right, before arriving at the final answer. Okay, so again, if you got multiples of or multiple of restrictions, then better plot it in the number line. So as we could see the intersection of all the restrictions. Okay, thank you.